Okay, question 9. R is a radar station located 120 kilometers north of a point P. You can see R is given to us there in the diagram. Okay, the rest of all this information here, it's all basically given to us here in the diagram. Okay? Part A of the question, the triangle PQR, so that's P to Q to R, this triangle down here, taken from figure 1 is shown in figure 2 by itself, and we're asked to find QR. So this is figure Q here, and we're asked to find QR. So it's the exact same measurements as in the diagram. That's basically over there, just out of shot right now. And we're asked to find QR. Now we've got the angle here, we've got a right angle, and we've got one of the sides. So I'm thinking trigonometry, I'm thinking SOHCAHTOA, the likes of sine, cos, or tan. Now I've redrawn this triangle, as you can see there, kind of on its side. Okay, with the angle, we're asked to find RQ, so I'm just going to call that, just call it the side X there just for a moment. So we're looking at opposite over hypotenuse. So that's obviously sine. Sine is equal to opposite over hypotenuse. So the sine of 30 is equal to what I'm calling X in the diagram, whereas here is QR. Just put a little X up there. QR over the hypotenuse, which is 120. That means that I multiply both sides by 120. So 120 times sine 30 is equal to QR. Okay, the sine of 30 is 0.5, and multiply that by 120 and we get 60. So the units there you can see in the diagram there, we're talking 120 kilometers, which means this is going to be 60 kilometers. That's QR. Right, on to the next part of the question. The triangle QRS taken from figure 1 is again shown over here on the right hand side. It's just kind of more blown up, as it were. Use your answer from part A to find QS. So this is QS there. Now we have just previously worked out QR. So you can see I've written that in there, the 60, that's QR, that's that side there. Okay, so again we're looking at a right angle triangle, and we know that one of the sides is 60 and the other side is 100. Now this is obviously the right angle, so that's the side opposite the right angle, so that will be the H, the hypotenuse. How are we going to work out this other side? This side here, SQ. But we can use Pythagoras theorem because it's a right angle triangle. So as I said there, A squared plus B squared is equal to C squared, C being the hypotenuse side. So I've put that in QS plus QR is equal to RS. So QS to be squared plus 60 squared is equal to 100 squared. And I've just done out those sums there like that. I got this as 3,600. Bring it over to this side. So QS squared is equal to 10,000 minus 3,600. 10,000 minus 3,600 is there, and we get the square root of that, which is 80. So the length QS is 80, and that's obviously 80 kilometers. Part C of the question, find PS. Give your answer correct to the nearest kilometer. Now PS, you can see in the diagram up here, is that short part of this line there, that yellow part there. Okay. So I'm saying we need to say PS plus SQ is equal to PQ. So what I'm saying there, again going back up to this diagram here, I call that the green side of it there. It's the yellow part plus the green part is equal to QP. Now we know what QS is, we've just worked that out in the previous part. It's 80. So we need to work out the larger part there, which would be PQ. Okay, let's go back up to the original diagram here for a moment. Now PQ is the, if I take this triangle here, this R to Q and down to P triangle. We know that this is 120. In part 1 of this question, we worked out RQ, bottom right of the screen there, to be 60. And we know that down here is a right angle. So we'll easily be able to work out this side here, which I'll just call X, but you can see from the main diagram there that X is from P up to Q. It's PQ. Okay, there is that triangle again. One side is 120, one side is 60, and we're trying to work out PQ. Okay, so we're using Pythagoras theorem again. Obviously, we've got a right angle here, so the side opposite it is our hypotenuse. I'll just put a little h there to make that obvious. Okay, so PQ to be squared plus RQ to be squared is equal to P R to be squared. That's the hypotenuse side there. Okay, PQ squared plus 60 to be squared is equal to 120 to be squared, and you can see all the calculations done out squaring those numbers. So 14,400 take away 3,600. This is my number for PQ squared. 10,800. So we get the square root of this will be PQ. 103.92 kilometers. That's the full length there. Now this question is asking us for PS, which is a point approximately somewhere in there is S. Now we already know QS, we've worked that out in the previous part of the question. QS there was 80 kilometers. So obviously using that, we'll be able to work out PS. So I've said there PS plus SQ is equal to PQ, and that coming from what I said earlier there, the yellow part plus the green part is equal to PQ. PQ there that I have just worked out. Okay, so left hand side of the screen here now, I'm just filling these in. PS and then QS that we worked out previously was 80, and then PQ, which we worked out over there. So PS is equal to 103.92, take away 80, which is equal to 23.92 kilometers. Question says correct to the nearest kilometer. So I'm just having to round this up to 24 kilometers there. Okay. Part D of the question. Consider the triangle RST using the cosine rule. So we're being told already to use the cosine rule, so that's great. Use the cosine rule to find an expression for cos theta, where theta is the measure of the angle TRS. You can see I have that kind of surrounded in blue down there, the angle theta. And then it says when you know that, hence work out theta. Alright, so we're being told to use the cosine rule. So the cosine rule is if you have a triangle, if you're going to call this the angle A, the side opposite it has to be the side A. And the other two sides then can make up B and C. I seem to have lost the ability to write the letter B. There we go. So we'll just remember that. So in my diagram here you can see that if I'm going to call this theta here the angle A, then the side opposite, in other words T to S, has to be A. Now let's go back up to the original diagram. So T to S is the side that I'm highlighting there like that. Now we know from our circle theorems that that Q there is going to be halfway. There's Q there, that's going to be halfway between T and S. Now we have worked out QS somewhere down here. There's QS there, it's 80 kilometers. Okay, so if QS is 80 kilometers, then this full green line, in other words from S up to T, will be double that. So twice 80. You can see me doing that there. TS is equal to twice of Q of S, and Q of S is 80. So in other words, the full distance there from T to S that line going up there, is 160. We're going to use that in the cosine rule as A. Okay, I've listed, as you can see here, this is my cosine rule. And I've mentioned about A and B and C already. So A is 160. It's coming from up there. B and C, we're getting them in the diagram here as 100. Both of them are 100. So that's plus 100 to be squared, plus 100 to be squared, minus 2 times 100 times 100 times cos A. That's 2 times BC. Alright, just squaring all those numbers out, you can see what I get there. 10,000 plus 10,000 add up to 20,000. And I bring that across the equal sign, and I get 25,600. Take away 20,000 is equal to 5,600. And then on the right hand side, I have minus 20,000 cos A. So if I divide across the equal sign by minus 20,000, I have on the right hand side, I just have cos A, and the left hand side, I have 5,600 divided by minus 20,000. I'm just going to add in there that I did that sum, and I got 5,600 was equal to minus 20,000 cos A. Just add that in there. So that's my cos of A. I was asked in the question to find an expression. Find an expression for cos theta. Okay, so I am obviously calling A, it's the same idea. Cos theta is equal to 5,600 over 20,000. You can divide that down if you like, but it's the same idea there. Okay, so the second part of this question then asks us to find, hence show that theta is equal to 106 degrees. So there's, I'm starting off again, cos A, what we know from what we've just worked out over there. Cos of A, or if you prefer, cos of theta. So dividing this down then, 5,600 divided by 20,000. Now I'm obviously dividing by minus 20,000. So whatever answer I get here, I'm going to say that it's minus 0.28. So that'll be cos of A is equal to minus 0.28. Let's pull that up on the calculator there, minus 0.28. If cos of A is equal to that, I need to find the inverse cos of that, and we get 106.26 there. Let me say that, 0.26. Again, to the nearest degree, and we're told that in the question, to the nearest degree, so that would be 106 degrees. Again, I'm calling that A there, the question, that's just coming from my cosine rule. The question is referring to it as theta. So theta is approximately equal to the nearest, the degrees to the nearest full degree, and the nearest whole number is 106 degrees. Now part 2 of the question, and this is I think the last part of the question, and it says, John sailed directly from S to T, in other words, just straight along this line there, that green line, and Mary sails from S to T along the minor arc ST. So basically Mary then does this kind of blue line there. So Mary does. Find the difference between the distances. Okay, T of S we kind of already know, as I'm calling it there, ST. That's 160 kilometers. We've worked that out there in question D, part 1. So we need to find the length of the sector of a circle. So the idea of a sector of a circle, and we see it down here. Okay, so the length of the sector with radius 100 kilometers and an angle of 106 degrees. So that's just obviously representing our angle there and our radius of 100 degrees, or sorry, 100 kilometers. So the arc is equal to 2 pi r times theta over 360 degrees. That's the length of the arc, okay? So it's 2 times pi times 100 radius, and theta is in there, is 106 degrees. There's theta in there. Multiply that out there, and it comes to, again, to the nearest kilometer, we get 185 kilometers. So the difference between the green line and the blue line in the diagram there, we just take them away. So 185 take 160 is equal to 25 kilometers. Okay, and actually I didn't realize there was one more part of this question. All right, part 3 of the question. The sea in this region is estimated to have an average of 1 ship per 25 square kilometers at any time. Use this estimate to find the number of ships in the sector RST. So we're going to have to find the area of the sector first of all. So area of the sector, pi r squared over theta 360 degrees. Now this will be theta in there in the diagram, okay? It's the angle. And obviously our r is the length of those lines there, which we know to be 100. So pi r is 100, r squared, and then theta is 106. So I'm just going to do that out there. We'll say it's, we'll start off with the squared part, 100 times 100. Multiply that by 3.14. Multiply that by 106. And then divide it by 360. And we get 9245.55, or if you want 0.56 to the nearest 2 decimal places. The question actually says to the nearest whole number, so we'll round that. It's at 0.55, so we're going to round that up to the area there is 9,246 kilometers squared. I'm using kilometers squared as my units because we know the length of these lines, we were given them before as 100 kilometers. Let's see there in that part there, 100 kilometers. Right, that's the total area of the sector, and we're told that in every 25 square kilometers there is 1 ship. So we need to work out basically how many 25 square kilometers are in this number here. So we'll just divide by 25. 9246 divided by 25, there we go, there is 369.84. Again, our answer says to the nearest whole number. So that's 370. Give your answer to the nearest whole number, that's 370. Bearing in mind in this, we're asked to find the number of ships. So basically, it's 370 ships. Okay, and that's the end of that 2019 paper 2 question.